Our next presenter is from Somerville, Massachusetts. Ladies and gentlemen, please welcome Daniel Shawnee from Energy Intelligence. All right, buddy.
Thank you.
Floor is yours. You got your thing. Go.
Good morning. My name is Daniel Shawnee. I'm the founder and CEO of Energy Intelligence. First, a big thank you to 43North and the sponsors. We're very grateful for the opportunity. Thank you to the judges for being here today. So over the past few decades, we've seen incredible innovation in energy technologies, and we hope to see continued progress in all forms of renewables. Still, we don't have a single solution for all our energy challenges, no silver bullet. We're tapping into a new source of energy that's going to waste all around us. The idea first occurred to me sitting in traffic on a drive home from work. When we think about traffic, we think about the energy wasted every time cars stop and start, when you push on the brakes and dissipate energy through heat loss, friction, pressure on the road. Of course, on open roads, you can't predict exactly where and when this stop and go happens, but there are lots of places where cars have to slow down. Toll booths, border crossings, truck stops, and it adds up to a lot of energy. In fact, a single truck slowing from 30 miles an hour to a stop dissipates about 1 kilowatt-hour worth of energy. That's enough to power your laptop for an entire workday from one stop. On a bigger scale, the 5,000 trucks that cross the Peace Bridge between here and Canada every day waste enough energy to power 170 homes, or to power both the Canadian and US customs plazas 5 times over. There are a few other companies from all over the world that have also recognized the potential of this opportunity. Their designs are too expensive, and they're too disruptive to site operations. In contrast, our solution is based on a simple design that generates better economics, is easier to install, and is going to be deployed with a business model that makes sense for customers. We're developing a hydraulic-based energy harvesting system. It's compact, flat, sits right on top of the road, and generates electricity from the motion of vehicles. When cars drive over a system, which is about the width of a lane, they're pushing pressurized fluid to spin a motor and generate anywhere from 250 to 2,000 watts of power, depending on the site and the volume of cars. With an installed cost of $500, payback ranges from 6 months to 2 years, but another way to look at it is the levelized cost, or the fully loaded cost over the useful life, which 7 cents per kilowatt is well below market prices and competitive with other sources of generation. Also, there's going to be room at most sites for multiple systems, and our modular design makes it easy to install these one after the other like Lego pieces. So here you see 5 systems connected, forming a larger installation and scaling output 5-fold. So every time a car drives over the system, it generates electricity, and that can be stored temporarily in batteries or sent directly to power a range of applications on site. So imagine, for instance, you're in a parking garage. The system can be installed at the entrance, the exit, or on down ramps between levels, and can power LED lights overhead, can power payment equipment, or signage. And this creates a closed loop for generation and consumption on site to reduce electricity expenses. This ecosystem around our technology lets us capture multiple revenue streams. So first, we're planning to own and operate the systems and sell the electricity generated back to the site owner based on discounts from market prices. So at commercial sites, prices will range from the 11-cent national average to as high as 24 cents in California. The difference between those prices and our base creates the savings for customers with no upfront cost. We also think there's a big opportunity here once lots of systems are deployed to sell data. What I mean by that is aggregated data for city planners and traffic authorities, or at a parking garage, reconciling data with payment logs to detect fraud. Once we're established in these sites, we see opportunities to work with partners and create more value. So these are highly visible locations. Unlike rooftop solar, here we have an engaged captive audience in the drivers. So as they pass through the garage, we can show real-time energy data on displays or messages thanking the drivers for their help. Using the same displays, we can do sponsorship and get referral fees from advertising partners that are doing the creative work. Similarly, by working directly with LED manufacturers, we can reduce the on-site consumption significantly, and with financing mechanisms like energy savings agreements, can take a cut of those savings as a project management fee. This is a big opportunity. There are lots of applications for this technology, and these are the three segments where we're first focused and think we can have the biggest impact. There are about 40,000 parking garages in the US, with many more cars passing through. We've partnered with the largest private company, Laz Parking, that has more than 2,000 facilities nationwide. They love what we're doing, and they're going to host our first pilot. From there, we scale up to more industrial applications like container terminals at ports. We can save a single terminal operator up to $200,000 a year, and with thousands of terminals across the country, the energy savings, or the potential, is big. Finally, when we scale up to border crossings, those in the US amount to more than 100 million vehicle passes per year. Those will take time to build up to, but represent a very big opportunity. And in total, the value of energy that we can generate across all targeted segments is estimated at more than $10 billion. Since founding the company, we've made a lot of progress and worked very hard for it. We've issued 2 patents, have several more pending. We've received 3 grants through competitive processes, and that money has gone to work alongside over $300,000 that my partner and I invested in the company. And that's to build prototypes, to conduct testing, and to push development forward. We have signed letters from 4 major sites that are ready and willing to host pilot sites. And we've spoken with a number of other interested parties for additional installations, and with large distribution partners that will be critical for this to succeed on a large global scale. We have an incredible team that balances the technical and business skills. I've been passionate about innovations in the energy space for a long time, and I worked as a consultant on large technology implementations. I founded this company when pursuing my MBA at the University of Chicago, and am committed to seeing it through. Nisim Shani, our COO, and my father, who's joining us here today, is a serial entrepreneur who has grown 3 high-tech ventures to exits and has experience in manufacturing and operations. Dr. Mansfield is a double PhD and 50 publications to his name. He was instrumental in formulating the IP strategy and is the systems architect. Dr. Hale has a PhD in mechanical engineering and specializes in carrying early designs all the way through to commercial build. And Dr. Vinay Krishnamurthy, experience in energy research and statistic modeling, is critical in terms of analyzing the data and working with that on a large scale. We also have a host of part-time folks and advisors who have been a critical part to get us to where we are today. Here's a look at our financial projections, and these are based on the revenue streams that I talked about earlier. So the revenues from the electricity sales from the road systems themselves will exceed $10 million in year 5, and that's with more than 5,000 systems deployed. When we think about our development timeline, we really expect to see an inflection in growth from those revenues in year 3 when scale manufacturing is up and running. Until that point, we can work with partners to capitalize on the other revenue opportunities and really move the business forward. In all, we expect to be cash flow positive between years 3 and 4 and generate net profits of $8.9 million by year 5. We've received a very warm welcome here in Buffalo this week, and we're thrilled to meet with local partners and really make the most of this opportunity. We hope to be a part of Buffalo's history of innovation and plan to hire and manufacture and pursue installations here. I'd like to end on an example that I think is close to home for most people here. The Ralph has a capacity of 74,000 people. That means more than 10,000 vehicles passing through on game day. We ran the numbers, and that volume of cars wastes enough energy to power all 360 stadium floodlights for more than an hour and a half. So we see this technology as a product that can help reinvent how we power our cities. We don't see it as the sole solution, but as an enabling technology that helps make our built environment smarter and more sustainable. So thank you all very much for your time, and I look forward to questions.
Smart move. Very smart move. I don't know. It didn't take a rocket scientist to figure some of this stuff out. Based on that, I think we have to have Kim ask the first question.
Yeah, if you want to help me out, I'd be more than happy to talk to you afterwards. You know, it sounds like a really great idea, but right now I drive a car and it stops. So when I stop at a red light, when I slow down at toll booths, some of the key target areas that you're shooting for installation, I drive a car that would make sense. So have you looked into the automobile industry and the fact that, you know, their energy savings and the technology that they have in the future would affect what you're trying to do?
There's no question that regenerative braking is making cars more efficient. The reality is actually it doesn't capture all the energy that's wasted. It leaves about 25% of this wasted energy on the table. So even with cars that are more efficient, focusing on the sites with a lot of volume that need lower energy on site, lower cost energy on site, the solution I think works hand in hand.
Is there a difference? So the different manufacturers, different types of cars produce different types of energy, or not types, but quantities of energy?
So if I understand the question correctly, the technology is based on the momentum of a vehicle and the weight of a vehicle.
Okay.
So the ways to produce more energy at a given site is more weight, so a truck versus a car,
okay.
More cars, or deploying more systems. So the bigger the car, the more energy.
Or the more you slow it down.
Right, if you capture it over a longer stretch of road or a bigger slowdown, yes.
So you said the life was 7 to 10 years.
Mm-hmm.
I'm curious how you tested that, because most roads seem to last about a year. And what happens when things in freezing weather, you know, it's like they're not in a nice lab, they're out on a road with a lot of dirty trucks and mud going over them.
Absolutely. Roadways are tough environments, so it's a good question. I'm from Boston. I've lived throughout the Northeast, lived in Chicago, so I know what a tough winter is. And so we've been designing the system to live through those harsh conditions. We do have the luxury up front with a big enough market to focus first on sites that are in covered environments. So within a parking garage, you have a bit of protection from those conditions. And even when we work towards the larger scale sites like the toll plazas that are more exposed, we can focus on the sites that are in sort of more moderate temperate climates. As far as the system components themselves, the limiting factors are actually really going to be some of the control components that have that critical life of 10 years. We absolutely have material science research still to do sort of on the structural parts of the rubber itself, but when we're dealing with relatively lower speeds, it can hold up for millions of compressions.
I actually have another question. If one thing I'm really interested in, if there's any way to make this cost effective, would be heated bike paths, so that people could bicycle in the winter, or ultimately heated roadways for snow clearing. And I suspect that the math won't work, but I'd be curious just to hear what you think about that.
Well, I mean, I love that idea. I think our notion is creating these ecosystems. So powering applications throughout cities, whatever they might be. If you find a stretch of road where this is relevant, it's easy enough to wire sort of conduction heating underneath the first layer of asphalt, and I think that would be possible.
Thanks.
Randall.
Talk a little bit about the competition. I know there are other people in this space who have different. Why is your technology better?
The short answer is it's expensive to dig up roads, and most of the other designs require you to dig about 2 feet deep into the road. And so what we found early on in conversations with potential customers is they don't want to shut down their site. They can't go offline for a few weeks to install a system. So by enabling that top surface mounted system, it makes a big difference.
David?
In looking through your application, it seems like your engineering designs and mechanical design has evolved from the hydraulic pistons into more of a linear fluid array, if I understand that correctly.
Yes.
Are you at an end stage, do you believe, on the mechanics at this point? I have another question after that. Go ahead.
Sure. Yeah, no, that's a great question. And the design absolutely has evolved over time. And I think that's the nature of most sort of mechanical systems, that as you work through different options, you figure out what works best. But to my last point, an objective in the design process has always been making the system more and more compact. And even in the last iteration with the pistons, we were down at about 4 inches and expected to mill down the top of the road surface. We decided that the benefit of compressing to about 1 inch in height by using the linear motion was sort of trumped all other benefits. And I do believe that we're at a final stage now. We've found that certain components for this energy regime, so this size and this performance, don't exist, and we've created custom designs and are going through the testing of those now.
Will there be any effect on the suspension systems of the vehicles? I mean, what will a vehicle experience? Will it be rough? Will there be bumps?
So the intention is when these are installed one after another, they're all at a uniform height, so it's like driving over a carpet.
Okay. And do you have a working prototype at this point?
We do. Right now we're working on our 3rd prototype. So in the evolution of the design, we have built real systems that I've driven over with many cars. So yes.
Bijan.
Yeah, this may be a crazy idea, but is there a way to build a version of this product that gets embedded in the car? So like, let's say you're a fleet owner, you've got 1,000 trucks, that instead of putting the mats down, it actually goes in the vehicle?
It's possible. That's maybe some hybrid between regenerative braking and what we're doing. I'd love to brainstorm on that. I'm not sure.
Okay.
Esther?
I just also wanted to say what a great storyteller you are.
Thank you. Thank you.
How about doing this in airports where there's a lot more weight, a lot more braking? The only issue is presumably you want it only when they're landing and not when they're trying to take off, because you...
Airport terminals for the cars are an easy starting point. My dream is runways. I think the FAA would have something to say about that, but working on it.
What is your biggest need if you're awarded $1 million? What is your biggest immediate need in the next year?
Right now we're focused on finishing the commercial design. So we want to build out the engineering team. There are a lot of points to fine tune. So that's the immediate question to address.
What about some of the applications you described, the parking garage? The need for electricity is going to be constant, but the generation is going to be intermittent. How does that work? Will you link it up with battery storage technology of some sort?
Yeah, I think depending on the application and the use of energy, there will be some storage almost as a buffer. What's nice is that at a lot of sites, they're using the most power when the sites are active and when cars are passing through. So even if you think about morning and evening rush hour, those coincide with peak energy usage times. And so that's where we intend to really deliver.
You're still going to have pulsing energy, not stable.
Right. So sort of the storage is what's going to create the buffer to deliver a smooth, continuous output.
Anybody else? Great. Thank you very much.
Thank you. Thank you very much.
Daniel, well done.
Thank you.
So what do you think so far of what your experience did with 43 North?
So far, it's been great. I mean, this week has been a blast getting to know the other finalists, and the 43 North team have been great hosts for us.
Great. Yeah. No, I mean, you're saying Chicago, you're saying Boston with their harsh winters, not ours. We have a much more moderate temperate winter.
I've heard the lake effect is nice.
It's no comparison. I'm telling you right now, no comparison. All right, my friend. Thank you very much. Well done.
Thanks.